Hi, welcome back to our Road to Steam series, a series in which we'll be creating a game from scratch. Previously on our Who's Dev Diaries, we transformed our scenery into a self-repeating environment. In today's episode, we'll add a depth of field effect to improve the readability of our game. Interested to follow the progress of our game? Make sure to subscribe and hit the notification bell to get all the latest development updates every week. With our environment fully implemented, it's time to adjust some key visual aspects to smooth out the gameplay experience. Compared to our previous scenery, our new environment is much more detailed and aesthetically pleasing. However, not everything is sunshine and rainbows. Like some of you have pointed out in our previous videos, the newly added backdrop impairs on the readability of the gameplay experience. Arrows and enemies now blend more easily with the environment, making them harder to stand out during fights. This is something we want to avoid for two big reasons. The first reason is that it goes against our core gameplay experience. Who's is a game where you need to identify threats quickly and clearly to deal with them. If this aspect of the experience is not upheld, everything else falls apart. Our second reason is that this type of visual overload can be strenuous on the eyes. It usually happens when an image is highly detailed, but low in contrast. If we go a step further and make the image move rapidly around the screen, it can even cause headaches or motion sickness. So, this is definitely something we want to avoid. To remedy this problem, we'll need to manually focus the attention of the player, so that it can ignore all the surrounding visual muddiness. The way we'll accomplish this is by adding a depth of field effect to our environment. In real life, you might have noticed that when you focus your eyes on a single object, the world around it starts to fade into blurriness. This is the depth of field effect in action. In essence, it describes the zone where visual elements are in focus. The smaller the zone, the blurrier the background becomes compared to objects that reside at the focal point. This technique is widely implemented in modern games to emphasize specific visual elements. One game in particular uses it to great effect. It would be nice to implement Doom's depth of field effect in our game, but unfortunately we can't do that. Because our camera renders everything in 2D, we cannot process the depth of our scene to create a traditional depth of field effect. To go around this problem, we'll need to fake it with an illusion. Normally in 2D games, depth of field effects are simulated by manually blurring images. This is done in painting programs like Krita, where illustrations are modified and then imported into game engines. The problem with this workflow is that blurred images can't be adjusted after they've been exported. If you want to tweak them, you basically have to restart the blurring process from scratch. To avoid this tedious way of working, we'll need a new approach. What we want is to be able to adjust the blur amount of any image once they've been imported inside Unity. Lucky for us, the answer is not too far from home. Over the years, we amassed a vast collection of useful materials while developing games. One in particular has the capacity to grant our wish. The Sprite Blur material. The way it works is quite straightforward. When you apply this material to a specific image, the image in question will become transparent and blur anything that's behind it. The cool thing with this is that the blur amount can be changed during gameplay at any time. This allows us to dynamically adjust our depth of field effect depending on what's happening in the game. To create our illusion, we'll use a combination of 4 blurry panels. 2 for the foreground, 1 for the middle ground, and 1 for the background. Our first 2 blurry panels are images that have the same silhouette as the panels they're blurring. The other 2, on the other hand, are huge square images that fill up the entire screen. We assign strong blur amounts to panels that are far away from the player, and faint amounts to those that are closer. Finally, for the cherry on top, we'll adjust the darkness of our first 3 middle ground panels. This will add much needed contrast to our environment, making our enemies easier to identify in the midst of battle. Now, let's see how all of these changes compare to our previous setup. Stay tuned for our next episode where we'll implement an outline shader for our 3D models. Make sure to like, comment and subscribe, and we'll see you next week with a new episode of our Road to Steam series.
Som lover hverandre sin tro, og den som skulle sige, skulle